Hello everyone, my name is Divyanshi Mangal. Today I'm going to demonstrate social network analysis tools. So I begin the search of the social network analysis and visualization tools from this website, karinakits.com, and here I found many interesting tools such as centrifuge, cometrix, egonet, etc. So out of these, there are a few tools that I have selected for the demonstration. So the first tool is Gephi. Gephi is an interactive visualization tool, and as we know that network analysis and visualization appears to be an interesting tool to give the researcher the ability to see the data from a new angle. So because Gephi is an easy access, easy to use tool, so we are going to use that, and it is also open source and free, so you can download it from its website gephi.org. And it is also of 70 MB, that is it is very small, so you won't have to worry about your data when you install it. So it will run on any major operating systems like Windows, Linux, Mac operating system, and it is a very powerful use, very easy to use tool. So we'll see how. So let us see Gephi. So this is the Gephi tool. I have not imported any data set till now. So let us import a data set. Just first click on file and a new project. So I'm already in a new project. So now you um, now click on data laboratory since we have to import the data. So when you click on data laboratory, you'll see import spreadsheet here. If you want to import the data in Excel format, then you have to import a spreadsheet. So my data is this one, Reddit edges. It is an Excel sheet. So now that data is getting imported. It will take some time because it is a complex data. Many nodes and many edges are there. So when this data is loaded, we'll be able to perform many type of statistics, and we'll be able to apply many type of filters on the data. So here it is. This is the data. These are the source, this is the target, and these are the weight between the edges. Okay, between the nodes, sorry, and these are the nodes. So make sure you import it as edges table since these are the edges, these are the nodes and edges kind of uh, format. So now when you click on next and then again finish, then your data will be imported. So now it is getting imported. So now as you can see, the number of nodes in our graph is 1131 and the number of edges are 7498. So it's quite a complex graph, and it is not a dynamic graph. Dynamic graph is one that keeps changing with time. Okay, it is neither a multi-graph nor a dynamic graph. Now when you click on OK, you'll be able to see the graph. Okay, so this is the ID, like this is the Reddit data that I have taken using the Reddit API. And as you might have heard, these are the subreddits, the communities on Reddits. So different communities are there. So you don't need to worry about that. You can import any data, you can perform any type of visualization. So when I go into overview, then I'll be able to see the graph. So this is the graph of the data. Right now it is very cluttered because there are many nodes, so you all the nodes are not visible, they are very near to each other. So now the nodes and edges statistics are given here. I can zoom out and I can show you these are the different nodes. Okay, so now what I can do is I can even change the layout of this. If I do not like the layout, then I can choose layout from any of this. Layout will change the appearance of the entire graph. So now if I run this Fletcherman green gold, then this graph will automatically begin changing and automatically begin taking the new shape as it is doing right now. Okay, and it will take a lot of time, so let us stop this. Okay, so now this is in Fletcherman green gold. It is just a layout, you can choose any other layout as well. So now what we can do is that we can apply, let me zoom it out. Okay, we can apply filters. What filters mean is that you can filter it according to various categories. Suppose you want the graph which has degrees less than degree greater than or equal to 4 only, then you can filter it using anything as type, as weight, mutual is, operator, okay, topology. So now we can filter it using degree range as well. So let me show you. Yeah, you have to drag and drop the filter here in the queries. Right now my graph has nodes with all the degrees. Even if a node has degree 1, then it is shown in this graph. But if I want the graph to have only those nodes which have a degree at least 61, okay, so if I filter it with this one, then I'll get my graph like this. Okay, now our graph has reduced, our nodes are reduced, nodes and edges are reduced. Earlier the nodes were so many, but now they are only 48, which means that only 4%, 4.24% of the entire graph is visible. And the edges were also too many, but now they are only 1033, only 13% is visible. So because I have applied a filter degree range, okay. And now you can use any other filter as well. K core is something in which every node has a degree at least k. And you can apply ego network, has self loop. If you want a graph in which the nodes have only have the self loop, then you can apply this, so you'll get the required graph. So now let us go back to our original graph. So this is our original graph. You can also apply statistics here. Various statistics are there, like average degree, average weighted degree, network diameter, graph density, hits, modularity, page rank, connected components, etc. So let us apply this first one, average degree. Let us find out what the average degree of our graph is. So the average degree of the graph is shown to us in a single click, and it is 6.630. You can also get the degree distribution graph. From this graph you can know whether it is a graph of Poisson distribution or power law distribution or anything else, and according to it you can also know the type of network model that you have to apply in order to get better insights. And also you can get in degree distribution, out degree distribution as well, since our graph is directed. So after applying average degree, we can get average weighted degree, network diameter, graph density. Let us run this one, graph density. Our graph is directed, yes, okay. So now the graph density is 0.006. The graph density is shown to us, and hits, modularity, page rank, connected components, all these stuffs also you can apply. Okay, let us apply the connected components. So we can see that the number of weakly connected components are 10, and the number of strongly connected components are this one, this much. Okay, so um, you can also find the average clustering coefficient, which is again a very useful parameter. An average clustering coefficient can be used to tell whether the random model or the small world model or a preferential attachment model can be applied. So you can know it. Average clustering coefficient for this graph is 0.265, and it is also telling that the mean value of individual coefficient is the average clustering coefficient, which we are already aware about. So a lot of things, average path length also same thing. It is also as useful as average clustering coefficient. So these are many statistics, and they are very used. They are very easy to apply. So let me go further and let me tell you how to change the color of the nodes, how to filter them by using betweenness centrality or closeness centrality, etc. Now you can change the appearance. So here I have selected color and ranking, and let me rank it using what? Just a second. Yeah, edges and ranking, and let us rank it using the in degree. And suppose let us change the color as this one and apply. Now you can see that the nodes which have more in degree, the nodes which have more in degree are darker in color, okay, and the nodes which have less in degree are lighter in color. So we have filtered it using what? Ranking. Okay, also there are component id, clustering coefficient, you can filter it using that also. Now what I can do is that I can also filter it using size. How to filter it using size is uh, let us suppose this is minimum size. Okay, 30. Apply. So now I filtered it using clustering coefficient. The nodes which have more size have more clustering coefficient, and the nodes which have less size have less clustering coefficient. So either you can filter it using colors or size, and you can, if you click here, then you can see the nodes level also. That is what is written on the nodes itself. Okay. So there are a lot of things you can perform with this Gephi tool, as you can see. Also, in data laboratory, if I go, then I can see that whatever I was calculating till now in degree, out degree, different type of graphs, and I found out strongly connected components, weakly connected components. So initially this worksheet was empty, only this ID column was there, only the subreddits were there. But now what we have here is we have everything that we calculated, clustering coefficient, so it gets stored here automatically, so you don't have to note it down every time. It gets stored in this data laboratory. Okay, so as you can see, Gephi tool is quite a powerful tool, and there are many kind of analysis that you can perform with the help of this tool. So now let us move to the next tool that I have selected. The other tool is Netlytic, and the best thing about this tool is that it is online. You do not have to download it, and it is again a very powerful tool. Yeah, to use this tool, first you have to create an account on Netlytic, which is a free account. You can also log in using Google. So after that, you have to import any data set. So let us go to new data set, and in this uh, new data set, you can import any data like YouTube data or Twitter data, Facebook data, any data you can upload. I had data of YouTube video, and you have to just provide the link of YouTube video. Okay, and then it will take the data automatically. So first it's asking me to sign in, so let's sign in using Google. It will take some time. Yeah. In this tool, in Netlytic tool, um, you can perform analysis on comments, uh, YouTube comments, Facebook comments, Twitter comments. So basically it is used a lot, and if you go to new data set now, then you will be able to import any type of data that you want. You can either import it in Excel format or any other format. So as you can see, we can import it from anywhere, and you just need to paste the URL. So I have already imported the data that I'll show you in my data sets. It is there. I just pasted a YouTube video link, and I wanted to see how to analyze that. So this is the data test. Okay, so this is a data of the comments from a YouTube video that I have taken. So yeah, as you can see, this is these are the comments given by different authors on the YouTube video, and it will also be filtered with description and like count, how many likes are there on that comment, reply count. Okay, and if the replies are there, then notes links will be formed between the notes. Okay, so that's how the graph will be created. Let's go to network analysis, and let us see the graph of this. um, I'll click on reanalyze since it will take a lot of time. I'll click on visualize. Okay, there are many comments on that YouTube video since it is a famous video. So it will take a little bit of time to form the graph. So it is building the network, and it will take 1 to 2 minutes for this, I think. Here also, let me explain you till then. Here also, you can change the layout, the node size, the colors. So it is actually a visualization tool. You can visualize anything, and if you zoom out, you can also see the actual comments. If you click on a node, and then you can see actual comments of the users that are given, and the links will be formed between the users. Suppose some suppose some user is commenting on some other user's comment, then a link will be formed between that user to that user. Now as you can see, the just a second. Yeah, now as you can see, the graph is formed. As I was telling you, there are different type of clusters. Okay, these are the nodes name. All this is the all these are the name of the users who have commented. So there are a lot of nodes in this. You can change the layout from here, and you can change the node size, the colors, and everything. Diameter, density, centralization, and everything modularity it is showing here. Okay, so if you remove this cluster one, then this middle part will be removed. Okay, since it's cluster one, it is also dividing it into clusters automatically. That's why it is known as auto clusters. So as you can see, Netlytic is also a very useful tool since it is online and it is free to use as well. So these are the kind of visualizations that you can perform with Netlytic tool. Also, there are many other network analysis tools that you can explore further, and I hope those tools will be as great as these tools as well. So thank you for watching the video. Thank you.